So I will do the introduction. So Anna, everybody knows, she is a postdoc fellow at the IQSS at Harvard, and her research focus is on the computational reproducibility, data provenance, and open science. She investigates how data repository can facilitate the reproducibility and what are the most common causes of the research, irreproducibility in deposited research. So in these projects, she collaborates with the Dataverse team. So
thank you so much.
Anna, you may start.
Sorry. Thank you so much for the introduction, and thank you everyone who stayed so long. Hopefully this is not going to be super long, and hopefully it's going to be a little bit interesting. So now I'm going to present a joint project that I've done with a few people, and here they are. So this is the whole author list. So me, Katie, who you heard, Kaylin, Sebastian, who is from CERN, and Marseille. And I'm going to talk on repository approaches to improving quality of shared data and code. And so what does that mean? So let's see. Okay, so introduction. So we've seen in this previous talks, and well, already, of course, we know, researchers share their data, code, and other materials to enable transparency, reproducibility, and verification. However, more importantly, this material should be shared to enable reuse, and reuse for other students and other researchers who want to build on it. And that's how the science progresses. But in practice, we know that this is not often the case, and it is not easy. This is because shared material is not always well documented, not understandable, and therefore not reusable. So we also seen that the reproducibility crisis has been reported for these reasons. So what was our idea? How did we start this discussion? So we know that data repositories are seen as a primary venue for research data sharing. So we understand that that's the case for research data at least. And then we asked ourselves, how can data repositories improve data and code quality? And how can they signal data and code quality to external researchers? Is there some thing that we can do, and is something easy that we can do at least, or hard? So how did we start off this discussion? So first, we had this small problem. How do we define data quality? What is data quality, and what can actually data repository influence? And then, given that all of us are coming from a little bit different background, we came up with 3 different approaches coming from computer science, information science, and human-computer interaction to kind of attack this problem. And given that most of our team is at Harvard at Dataverse, working with the Dataverse data repository, we try to apply these approaches in practice. So essentially for this talk, I'm going to present these 3 different approaches, and I'm also going to show how they're applied in practice. Okay, so first, just what is Dataverse? So we're probably having attendees from all over the world. So here is just a short introduction of what Dataverse is. Dataverse, or at least Harvard Dataverse, is a multidisciplinary research data repository that allows essentially anyone around the world to deposit, publish, and share their data sets. And in particular, Dataverse repositories are based on the software, on the open source software that different institutes can run to use as an institutional repository. So here we actually see that around the world there are many installations of Dataverse. And here we can see, there are 67 installations around the world of Dataverse, and we can see where they are here on this map. And that can also be seen if you go to dataverse.org. All right, so now going back to our problem and going back to understanding how we can define data quality. So initially, we tried to define data quality ourselves. We had some definitions, but then we realized, okay, wait, there are probably so many people already thinking about this problem. So let's kind of just look out of the box. And of course, there are people thinking about this long and hard. And here are some of the things that we found in the literature. So Kan Zhu and Martin and his co-authors have defined this, the data quality. And here are just some of the things from these papers, and here is the alignment of these things. So there is, of course, availability, usability, reliability, relevance, and presentation quality, and the other things. And as we try to align these different features, we also want to understand how can data repositories influence these things, and what are the examples of data repository features and functionalities that address these things. So for example, minting DOIs is something directly connected to availability, because these are then they have their own unique ID, and they can be accessed in most cases. And then when it comes to usability, we have supporting documentation, reuse licensing, access, restriction, and that's something that data repositories manage. Then we have reliability and different metadata standards, variable levels metadata, and so on. The data repositories can do. And then for relevance, we have reuse metrics, preview options, granular descriptions. And then for presentation quality, we have other services that actually do that, like Cure, or services that advise on how to publish data sets. And finally, we have some support in addition to something that is like directly visible from the interface. So okay, now what can we see? What can we conclude from this? So while some of the quality dimensions, some of the data quality dimensions refer to the intrinsic qualities of data files, such as accuracy, integrity, and completeness, and these are the ones that researchers themselves kind of manage, and of course this depending on how they design their experiments and how they collect data. Several other important features can be improved by data repositories, and these features include presentation quality, documentation, metadata, accessibility, and so on. Okay, so then we kind of landed on approach number one. What can we do with the curation features, and how can we encourage the use of curation features? So when it comes to Harvard Dataverse and Dataverse, anyone, especially Harvard Dataverse, anyone in the world can deposit their research data. However, there are some specialized groups like journals, laboratories, and project teams that curate their own collections on Dataverse. And they essentially, they can approve or disapprove of what's going to be deposited on Dataverse. And the software itself supports review workflow that allows these curators or managers to ensure that the deposited data sets meet group-defined expectations. So what are these expectations? So what influences data quality? What are the influences of data quality? Or even better question, what's researchers' perception of data quality? So that's, of course, reputation of a repository. So it is a little bit different if a researcher finds their data set on GitHub, on another researcher's personal website, or somewhere else. So that's like one thing. And then the second thing is the use of optional features in a data repository. So these like additional features, so essentially it boils down to the more excessive the use of optional features, the more fair, so findable, accessible, interoperable, and reusable the dataset is likely to be, and the people are more likely to think that it is of high value, and even further, it is actually of higher quality. So that led us to a little bit investigate this use of additional features and the features in general in Harvard Dataverse. So we pulled different dataset characteristics and particularly looked into what happens when a dataset was reviewed before publishing and what happens when it's not. So here we can see that on average, description length of a dataset, keyword count of different versions of a dataset, so how many times it was republished, and count of optional metadata fields used were all higher when a dataset was reviewed. And these are particularly important as they're used both kind of like this additional metadata features and description length, they're used for essentially they're used for crawlers by search engines like Google Dataset Search. So what do we conclude? What do we see here? So we find that data depositors often do not adequately document their data sets. So essentially, prior review, and in particular mandatory fields, can improve the quality of curation and the quality of data sets. And also, what is another important thing to keep in mind is that we find that articles linked to publication data often include contextual information that metadata cannot sufficiently capture. And furthermore, this goes like the other way around, and that academic literature remains the primary avenue through which researchers find and evaluate their secondary data. So that kind of corroborates the fact what Qian just pointed out, is that we want to encourage bidirectional linking between publications and data sets to facilitate this direct access between them. So therefore, citing datasets across the scholarly record and would make them both findable and better documented. And that is, so findable through the references and also better documented, as that is something that is used as more contextual information of how the dataset was collected. Okay, so then we discussed the second approach. The second approach concerns the code completeness. So, and it is ensure code completeness. Well, so what happens? Research code is a common element in many datasets nowadays. However, there are a lot of challenges in sharing code. Research code is dependent on software, on operating system, on hardware, and these things are not often very well documented in data repositories. And in order to learn more about this challenge, we conducted a study where we pooled about 22 publicly available replication datasets that contain Python code. So first, we examined them and tried to see whether they contain files like requirements or documentation to understand what's there and how to rerun them. And then secondly, we try to automatically or naively rerun them, re-execute them using Python 2.7 and 3.5. Giving each of the files a time limit of 10 minutes per file. So what happens? So first thing that we see, do datasets contain documentation and the record of code dependencies? So in most cases, yes, actually, more than 50% of the datasets contain documentation, so 62%, either had a README file, instructions file, or a code book, which is good, but can be improved. However, on the other hand side, we see that almost none datasets contain files such as requirements.txt, which is a common convention for capturing dependencies for Python code, or environment.yaml, or Dockerfile. So neither of these are present, and that is definitely a room for improvement. So what happens when we re-executed this code? So we find that on average, around 27% of the files were re-executable, were rerunable. And then if we look at a little bit more higher level results, we find that only 44% of the datasets contain at least one Python file that executes with success or does not crash with error. So what does that tell us? These results show that further support is needed to document research code in data repositories. And in particular, we see that those datasets that had requirements.txt had also on average better re-execution rate. And even though we try to kind of like scan the code in advance and see what needs to be pre-installed. Okay, So here are some of the actionable steps that kind of belong to the approach too. So encourage storing environment files in datasets. So in particular, these are the files like requirements.txt for Python or install.r for the R programming language. And this can be implemented like a pop-up window or the user instructions. And I was very impressed seeing this like user instructions that Mandy presented today. That looks very, very nice and detailed for people to use. So something like that would be probably like a great thing to encourage the use of these very valuable files. Second, we have this kind of like more advanced approach, and that is an integration with reproducibility platforms that use virtual containers and encapsulation. And virtual containers are essentially deemed irreplaceable for capturing all these dependencies relatively easily. So examples of these projects are Wholetail, CodeOcean, Binder, Ranku, and these are some of the already incorporated in Dataverse, and some are considered by the open source community, Dataverse open source community. Okay, so here we have an example of this approach. So we can incorporate a binder button in Dataverse and rerun the code. And also from the binder side, there is in a drop-down menu, you can find Dataverse DOI and then rerun your analysis. And it's only going to work if you already have this requirements.txt file present in the repository, in the well, dataset in the repository. All right. So now we speak about approach number 3. So that is a little bit something a little bit different, maybe. So we spoke about incorporating different gamified design elements. So what is gamification? Gamification is the use of game design elements in a non-game context. Badges, points, leaderboards are some of the most common game design elements. And you've probably seen them in like language learning apps, teaching, citizen science, health applications, and other apps on the phone, especially. So we want to see whether we can use these gamified elements to encourage data sharing. What would happen? Would this work? So it turns out that there are already some studies done on that. So we kind of like conducted a secondary study on this and learned that gamified badges, that they were identified as the most suitable element to incentivize data sharing. So from the perspective of researchers, they're seen as an achievable goal, while also improving visibility of their papers, and also with that potentially improving citation rate. So that is done in a CERN study, but also it was reported that open science badges incentivize data sharing for medical use. So when it comes to the gamified design elements, there's twofold benefit in using them. So first, second, in addition to motivating researchers, for example, with a badge, these gaming elements can be used to identify resources of high quality within an available resource pool. So a great example of that is the star system in GitHub. So we can see that datasets that have a high star count are probably like graded by the peers, by the community well, and we can kind of like identify them immediately, right? And then another example is a SOC archive, the social science archive, and they incorporated this small element that you can kind of like give a small applause to the paper. And also rate it as robust, clear, exciting, and so on. And that is a great element that kind of like help us identify as a good source, like a crowd-rated source, if that makes sense. And if we had to choose between two things that are maybe very similar, we can choose the one that our peers rated higher. So there are also this other interesting number, so a dataset metric. So a high number of downloads can signal popularity of a dataset. However, it is not completely equivalent to these things that we spoke about, and that is because of the long tail of science. So what does that mean? That big science data products, like CERN data, is used by a large number of people, and hence they will have this like large download count. Whereas small data sets are used only by a small number of specialists. And the interesting thing is that there is like so much more of these like small data sets. They're much more common than these like big science data products. And that's why the download count that we've seen in the previous slide is not a reliable metric. And that is something that we need to keep in mind. Okay, but a good example of this approach is these open science badges that Mandy showed earlier today. So open data, open materials, and it is something that obviously showed very good results. Okay, so I would like to conclude with that. So in conclusion, I would like to say that data repository features and services can contribute significantly to the quality and reusability of shared datasets. So in particular, in this talk, I explored these three different approaches. And one is to ensure that runtime environment components for code are present. They should be encouraged. Second is that repositories can support a workflow with prior review, which often results in better curated datasets. So that is something that we shown in this study. And finally, including gamified design elements have the twofold benefit in both promoting and encouraging data sharing by providing recognition, but also they provide a user metric for data reusers who can then identify this resource better. So I encourage you to check out our paper that just came out a few days ago, where you can find out more about these approaches and the methodology in more detail. Yeah, so you can see the DOI. And yeah, I think that's everything. Thank you very much for your attention, and I'm happy to take any questions.
Thank you, Anna, for your talk. Very nice. So I have seen one question in the Q&A session from Lisa Truston, I think from Data Curation Network, who is asking, when understanding the data quality influencers, how did you capture the researchers' perceptions?
Yeah, that's a good question. It is well, for that we used literature review. So what was kind of like already recognized in the literature as data quality, we then kind of cited this previous work and then started from it.
Thank you. And one more question from Q&A is that, could you please post the link of the paper you mentioned in the last slide? I think that's easier question to answer. Yeah, thank you. And also I have one question. Yeah, some thoughts about the Dataverse. So because you mentioned Dataverse has been installed, around the world, and each institution or organization may have their own, instances of the Dataverse. So I haven't seen, from for example, the scholarly Dataverse in Canada, I haven't seen this the code sharing part. So my question for Dataverse in general is that, do you have the same, when you are sharing code and data, do you have separate licensing for the users to choose from when you do share them, on the Dataverse? Okay, you are nodding your head. That's good.
No. Well, okay, that's a good question. It is more complicated than that. It is in a sense that, yeah, for data sets, yes, but Dataverse currently does not support licensing for code, and that is kind of like an ongoing discussion. It is a hard problem right? So we are kind of like trying to incorporate also like licensing for code. Yeah.
And in your screenshot sharing there, try to re-execute the code there and the data. So one thought in my head is that when do you determine the data is the main product of the research that you are going to share, and associate that specific code is trying to read and process that data for the research reproducibility purposes, or you just, because I think it's not fair sometimes if I'm just sharing my data, but I put the data is what it is for and what the description, and I didn't put any actual code there. But I do have a comprehensive documentation talking about, okay, this data can be read and with specific software or something like, and you will have a view of visualization of that. So in that case, what how do you determine the significance of this code or data? Or if your primary output is code, then as Titus mentioned earlier, that you might need to put a test case there. So that data will be just for test using purposes. So how do you determine all these different purposes? And also when you have multiple code associated with different partition of your data sharing, how do you manage this, DOI, and also, the management of the different products in one place? Because at that time, without full documentation, you are not able to re-execute the code there to have the expected outputs data out there. So.
Yeah, that's a good question, and that's a hard problem. And the thing is that, yeah, I mean, it is true that currently all these different resources are kind of like bucketed all together in a data set. So essentially people can deposit both the data sets and code and, documentation, README, and other things. But yeah, there is essentially not a very good support for all these different components yet, though it is something that is currently also in a discussion at Dataverse. For example, like a natural way to support this would probably be a research object. And then also research object also incorporates this information on how these data sets, how this code should be re-executed. So yeah, you're right. It is really hard to correctly re-execute the code without actually reading the documentation. But yeah, with some like minimal automation that can be done.
Yeah,